Hi, so today's lesson is called tourism. Now, on my page, I've got three pictures. Okay, so I've got this one here that looks a bit like a house, this one here, and this one here. And these are all types of graph. They might not be the type of graph that you're used to seeing in maths, but they are a type of graph. And what we're going to be doing today is figuring out whether we can draw these in a special way. So we're going to figure out if we can draw them without taking our pen off the paper and without going over any line twice. So that has a special name if we can do that. If we can do that, we say that the graph is traversable. So if it's traversable, it can be drawn without taking your pen off the paper or going over any line twice. And we're going to figure out if there's any special things about these pictures, about these graphs, that mean that decide whether a graph is traversable or not. So I'm going to have a go at trying to do this one. Okay, so I'm going to start here. If I was to go across, it might take a few tries. Across there, up there, up there. Okay, so that time I failed because this line, I haven't drawn it completely. And to get down here, I'd have to go either back across that line or down there. So that time it didn't work. Let's try a different route. So this time I'm going to start here. So last time I started down there. This time I'm going to start here. So if I went up there, down there, across there, down there. Okay, that time I did it. So I started there and I went up, down, across, down. I ended here. So that was the start and that was the end. Okay. So I started in one place, I ended in another place. Maybe that's something that we might want to think about. We also might want to see if we can notice anything. So think about what we could count. So all of these graphs are made up of dots and lines, and there's special mathematical names for them. So the dots are called nodes. I'll remind you of that word later. This graph has 5 nodes. 1, 2, 3, 4, 5. So it's got 5 nodes. Altogether, we could count the number of lines. Now, the special word for the lines is edges. That's the special mathematical name for them. There's 1, 2, 3, 4, 5, 6. 6 edges altogether. Don't know whether that's going to be useful. The other thing that I might want to think about is how many lines come out of each node. So how many edges come out of each node? And that's called the order of the node. So this one down here has 2 coming out of it. This one has 2 coming out of it. This one has 3 coming out of it. This one has 3, and this one has 2. So maybe those numbers might be useful. I can't think of anything else that I could count about that graph at the moment, but maybe I've missed something. Maybe you can think of something else. Okay, so let's see if I can do the next one. So I'm going to try and traverse this one, try and draw this one without taking my pen off the paper or go over any lines twice. Okay, so that didn't work. That way didn't work. Okay, so you'll have a bit more time than me, but I would carry on trying that for a while. Okay. And I think that I would find in the end, well, I know because I've done it before, that this one is not traversable. This one was traversable. Okay. So let's quickly count all of the things here, because we also, we want to count when it does work, but we also want to count when it doesn't work, so that we maybe can spot some patterns. So here I've got 4 nodes. I've got 6 edges. And the orders, this one's got 3 coming out of it, 3 coming out of it, 3 coming out of it, and 3 coming out of it. So they've all had order 3. Okay. Let's try this bottom one then. It's the last example I'm going to do with you. I think this one actually looks like it might be quite easy. So I'm going to start here. I'm going to go round. I'm going to go around all the bendy ones to start with. And then I'm going to go around all the straight ones. Okay, so that was quite easy. I just went like that. And I started and ended at the same point. Okay, so that one was traversable. And then if I count the number of nodes, there's 4 nodes. There's 8 edges. And then if I count the order of them, so the number of edges that come out of each node, this one's got 4 coming out of it. This one's got 4 coming out of it. This one's got 4 coming out of it. And this one has also got 4 coming out of it. So they all had order 4. So your challenge is to try and figure out what makes a graph traversable. Okay, so you might want to think about the number of nodes, the number of edges, and the order of them. So a reminder of those words. The nodes are the big fat dots, okay, where all the edges meet. The edges are the lines, and the order of a node is the number of lines coming out of the node. Okay, so that one would have order 2, that one would have had order 3. And then the word traversable means that it can be drawn without taking your pen off the paper or going over any line twice. And I want to see if you can spot any patterns and figure out what makes a graph traversable. You can make up your own graphs, but if you're stuck, there's some graphs on an attachment on the task. If you're finding it really tricky, you can just try and draw them. Try and draw them without taking your pen off the paper. Okay. If you want to do the main task, it's to figure out what makes it traversable. And then if you want an extension, maybe you could think about this one here. We started and ended at different points. And this one here, we started and ended at the same point. Maybe you could figure out what affects which of those situations happens. Okay, right, off you go.